Alright, welcome back. And let's get practical here and actually go to something that's a little bit complex, and that is using the Fibonacci number. So let's do a program that computes the Fibonacci number. What is the Fibonacci number? First I'm going to create a new class. I'm going to call this Fibonacci app and give it the main function. And Okay, so the Fibonacci is defined, so Fibonacci number is defined by the sum of the two previous Fibonacci numbers. Okay, so that may or may not help us too much. What does that mean? So in other words, the Fibonacci, and we have these two definitions, right? So we'll say fib of 0 equals 0. And fib 1 equals 1. Okay, so we'll say fib 2 is fib 1 plus fib 0, which is 0 plus 1, which equals 1. Alright? Fib 3 is going to be the Fibonacci number of 2 plus the Fibonacci number of 1, which is Fibonacci of 2 is 1, which we just found that out, and Fibonacci of 1 is 1 equals 2. Okay, fib of 4 equals fib 3 plus fib 2, which is going to equal, so Fibonacci number of 3 is 2, Fibonacci of 2 is 1, so that is going to equal 3. One last one just for the sake of demo. Again, Fibonacci number of 5 is fib 4 plus fib 3, right? So we go the two previous Fibonacci numbers. Fibonacci of 4 is 3, right? Fibonacci number of 3 is 2. So the fifth Fibonacci number is 5. So this is similar to factorials, which maybe we can do that as a lab. But let's do the Fibonacci number. So I'm going to come down here and say public static int fib, and we'll say int n. Okay, so we're going to compute the Fibonacci number. Now, to know the Fibonacci number, you need to know the two previous numbers, right? So let's first say if we have this condition, right? So if our n is equal to 0, then we're going to say, well, our number is 0, right? So if the Fibonacci number of 0 is in fact 0. Else, if our number is 1, then we're going to return 1, right? By definition, the Fibonacci number of 1 is 1. Okay, so we have this stuff, which is pretty easy. What do we do now if we have this condition, right? So what about the Fibonacci number of 3? Well, the Fibonacci number of 3 is the Fibonacci number of 2 and 1. And so we can say here, we will return the two previous numbers, right? So we want to return Fibonacci of n minus 1 plus Fibonacci n minus 2. Okay? It's fib, not Fibonacci. Okay, so in other words, again, let's think through this. If n is 0, then this will execute. It will return 0 right away. None of this other stuff will execute. It's going to return 0. If n is 1, it will return 1, and then it's not 0, so this will evaluate to true, and then it'll quit once it's at 1. Once n is 2, then now that these are going to be true, it's going to go down to return this expression. This expression is what? It's going to call fib 2 minus 1, which is 1, and then 2 minus 2, which is 0. So it's going to call, this will evaluate to Fibonacci of 1, this will evaluate to Fibonacci of 0, which again we have right here. So it'll call basically two separate functions. Once again, when this is 3, these will not execute. Then we're going to have the Fibonacci number of 2 and Fibonacci number of 1. Fibonacci number of 2 is the Fibonacci number of 1 and 0, and so forth. So This idea is called recursion, and it's a pretty helpful tool. Anyway, let's make sure that this is working. So we're going to call fib. First of all, let's say fib 0. And I'm going to say, let's print out Fibonacci number 0. Print that. We get 0. Okay, good. Fibonacci number of 1 is 1. And what about 2? There we go. And 3. Okay, good. So we can, if we wanted to, we could actually debug this, but essentially this is a series of zeros and ones that we're adding together, actually a series of ones and multiples of ones, right? So anyway, we get the idea of how this works. And so again, we use recursion here, which is a maybe probably a new idea for you, and it does take some time for people to kind of wrap their head about it. But again, think of, let me add one more set of parentheses here. So think of this as one expression, and then this as another expression, right? And so this is going to evaluate, and this will evaluate, and then basically the program is able to separate these functions out and then recursively go back and forth until we have basically again n equals 0 and n equal 1. So that's recursion, and that's combining again functions, and actually we don't have loops here. It's almost like a loop. You could write this as a loop, but recursion is kind of a neat way to also it's a good trick to know. So anyway, this in some ways is a little bit more of an advanced topic, but I'd like for you to get introduced to this. And at any rate, hopefully this is helpful. And what I'll have you do as an assignment is do the same thing. Instead of the Fibonacci number, do the factorial number. So the factorial number is so something like, 1 factorial is 1, which is 1 times 1. 2 factorial is 1 times, actually it's 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1, and so forth. So you get the idea. So we'll do that as an assignment. Anyway, and hopefully this obviously will help you kind of give you the intuition as to how to do the factorial.